INI, right, the Applied AI Research Institute. So I'll give a little bit of background. I think you already got some background on my career so far. Right? So I work at Intel, been at Intel for the past 25 years. Right? So I graduated from SRKR, right, which is not too far away in Bhimavaram here. Right? After that, I did my masters and then joined Intel. So I've been in Intel for a long time, and over the past over the past 5-6 years, right? Intel has been having conversations with the central government mostly, and a lot of state governments, and also the academia, right? In terms of using how we can do a better job of using AI. Right? AI has been a buzzword, right, for the past 5-6 years, and even your college completely transformed, right, from doing all the other courses to being AI centric, right? So what we wanted to do was, instead of everybody doing their own thing, the industry doing their own AI stuff, and then the academia doing their own stuff, and the government doing their own stuff, we wanted to bring all these parties, three critical parties together: industry, government, and academia, under one umbrella, and use AI and other technologies to actually work on real solutions that will have an impact on the society. Right. So this is one thing that is always asked whenever you work on some technology. Right. It's good that you can do some research, publish some papers, okay, develop some products, but ultimately, how is that helping society? Right. So that's the goal here behind this Applied AI Institute that we got together with IIIT Hyderabad and the government of Telangana, where we started this Applied AI Research Institute called INI, where we wanted to use AI to actually solve some real problems. Right. So with that goal, we picked two domains. Right. One domain is healthcare, and the other domain is smart mobility. Right. Within these two domains, we wanted to do projects that will have actually, you know, get deployed out there in the society and have a real impact. So under the smart mobility, we have multiple projects, and iRASTE is one of our flagship projects. Also, I'll talk a lot more about that. But before I go into smart mobility, I'll talk a little bit on the healthcare projects. Right? And the reason we chose these two is because these are the ones which are most relevant for our country. Right? Healthcare, I don't need to explain to you, right? There's a lot more we can do in terms of improving our healthcare facilities, right? And especially given that AI needs a lot of data to build these algorithms, right? And we have a big population, and we have a lot of data available, right? So if we can harness all that and actually use that to develop some solutions to solve our real problems and improve our healthcare efficiency, right, we'll go a long way, right? So that's one reason to pick healthcare. And the second one, mobility. Again, the goal here is actually to reduce the number of road accidents that we have. So if you see the statistics out there, uh, worldwide statistics, our country has the highest number of accidents and deaths compared to any other country in the world. Right. So our goal is, can we do something about it using this AI-related technologies to reduce those accidents? Right. So that's the reason we picked these two domains, healthcare and mobility. Right. And in terms of focus, right? Okay, you pick these two domains. How are you going to go about it? Right. So if you see healthcare, the sort of three broad domains, right? The first thing is screening, right? And this is where we don't do much in our country, right? Where a lot of the focus is on tertiary hospitals, right? Big hospitals where you go after you already have a disease, right? But the ideal thing is that you do enough screening so that you catch the disease in the very early stage, right? That's where you can have the biggest impact, right? Once you have the disease, it's really about disease management, right? So if you can screen for something at the very early stage, right, then that's where you'll have the biggest impact, right? So I'll talk about a couple of projects we have in that area, right? And then that's the first one, screening, right? Identify as early as possible, right? And the second thing is diagnosis. Okay, if you can't catch something, you already have some sort of disease, then how do you diagnose, and how do you diagnose it in a better way? Right? That's the second stage. The third stage is intervention.
Okay, you already have the disease. Now you need some sort of intervention plan, some sort of drugs, right? I won't talk too much about the third vector because we're doing some good work, but it's still we haven't publicly talked about it, right? Uh, all I'll say is if you see how the drug discovery process happens today, right? From the time a company starts identifying a drug and the time it comes into the market, it takes around, typically 15 years. They spend billions of dollars to do that stuff. That has been what is happening over the past 50, 60 years in the drug discovery space. But if you see what's happening in the last 5, 6 years, there are almost like 200 to 300 startups in the drug discovery space where they're able to do a lot of this pre-work in terms of how the molecules interact. So the lot of pre-work is how these drugs interact with your body. So you need to do a lot of this work. So with these new AI methods, companies are able to do a lot of this work in the simulation, and then actual wet lab where you take the drugs and test them, right? That can be very small. So this entire 15-year process now is getting squeezed to almost like 3 to 4 years, right? So AI is having a really big impact in that domain, right? uh, and a lot more actually in terms of genomics, right? The rate at which uh, the field is changing, where pretty soon you'll get personalized medicine. Each one will have your own medicine because the medicine will be based on your genetic profile, right? So I won't talk too much about it because that's too big a subject, right? I'll talk about the other stuff. Okay, then on the mobility side, the first one is road safety, right? So that's where we have this projects called iRASTE. I'll talk about that. Again, the goal is, you know, see if we can save, reduce accident, and especially save lives, right? That's the first one, right? The second one is road experience, where we have a lot of solutions using this data and in terms of automatic identification of a lot of these parameters on the road, right? And also enforcement solutions, right? In terms of catching people violating, whether it is the no helmet, triple rider, a lot of these things, right? Now that you have a lot of cameras, using that data from the cameras, you can do a lot of this automatically. You don't need to sit manually and do any of this, right? And the third one, it's called IDD. I'll talk a little bit about it. It's short for Indian Driving Data Set. This is something we've been doing for almost 5, 6 years now, which is this data set is the data set of Indian driving conditions. So if you see all these algorithms that are being developed, especially for cars, a lot of the data sets out there are based on Europe and US conditions. There is no data set out there for Indian driving data conditions. So this is one of the first thing we did, where we equipped the car with bunch of sensors. They drove all around India and actually have a good data set, right? And the last one is platforms, actually building platforms to capture the data and build autonomous driving solutions. So this is the entire different vectors that we work on at NI, right? And I'll talk about projects specifically in each one of these. Okay, screening, right? So this is a very specific project, and if you see how our disease profile for the country has changed, say over the last 40, 50 years, so since we got independence to where we are today. Earlier, the government's biggest concern used to be communicable diseases, right? TB, malaria, anything that is communicable, right? We have come a long way where that is not a concern anymore, and now the non-communicable diseases are our biggest concern. If you see, go to the hospitals and see what is impacting cancer, cardiovascular diseases, and diabetes are our biggest concern right now. Most of the people are impacted by these things, right? So in these, right, the particular one, so if you see chart on the right, that is showing various countries and oral cancer, incidence of oral cancer, right? And you can imagine that big red spot out there, which country is that? Our country, right? So we have the biggest incidence of oral cancer in our country compared to anybody else out there, right? And the thing is, oral cancer, and a lot of it is due to tobacco use, but that's not the only reason, right? The thing is, the oral cancer, from the time it starts to the time it becomes cancerous. So let's say something starts in your mouth, to the time it becomes cancer, it takes almost 10 years. So you have that long a time to actually detect it. So people have been neglecting for that long, right? So if you can catch it anywhere in that time, you can actually completely get it into remission, right? So this is one of the reasons we selected this thing, where our solution right now is, you take a just a regular camera, right? And then we give it to the nurses or whoever is working in the clinic. They take around 5 to 6 pictures of the mouth, and then we develop the algorithms where the algorithms look at all those images and then see if the lesion is suspicious or not suspicious for cancer, right? So if we can develop such simple solutions and can deploy in any clinic out there, right, it will go a long way in terms of screening at the very primary healthcare center level. So that's the goal here. So right now our algorithm is at like 80 to 84% efficiency. So, and we have a path to get to 90 to 95%. Right? So when I say screening, this is a kind of stuff where we can have very simple solutions that using AI can be deployed at the very basic primary healthcare center level, that can have a real impact out there and actually save lives. Uh, this is one of the partners we have. It's called the Grace Cancer Foundation. They have around 5 of these buses, right? So they have the buses, and these buses do only one thing: cancer screening. So today they don't go out every day. The bus can go out every day. They don't go out because the doctor is not available, right? So with a solution like this, they can go do all the screening, right? And then only the suspected cases the doctor can see later, right? So that's the idea. There's a lot of infrastructure available, but the doctor is not available. So these AI-based solutions are really to help the nurses and the folks in the clinics to do something without the doctor being there. So the doctor can only look at the suspicious cases. So that's one. And the second one, we actually started a pathogen sequencing lab. So I think with the past 3 4 years now, everybody is familiar with the term variant, right? Because every 3 months there is a new COVID variant, right? So now we know what variants means, how viruses mutate, and all that stuff. But this is how viruses were there for a long time. Nobody bothered until COVID came along. So if you see TB, for example, right, there are 23 different variants of TB, right, and a lot of them are becoming drug resistant now, right. The thing is, when somebody with TB goes to a doctor, right, the doctor doesn't know, and then he prescribes. So for TB, by the way, the doctor has to give a cocktail of drugs. They combine a lot of drugs depending on exactly what their variant is, but the doctor has to know what it is. So for the doctor to know, uh, right now they do lots of tests. Okay, go do this test, go do that test, and it's an iterative process. And sometimes it takes a lot of time, and then you find out, oh, this is not this variant. Then you wasted 4 months, and then you start another cocktail. In the meantime, the people don't take those drugs, right? So there's a lot of issues. So if you can actually, right on day one, you can sequence that genetic sequence, and find out exactly which variant is it, then the doctor can really prescribe the right medicine right there, right, and compress that entire cycle. So what we're trying to do here is come up with, if you today if you want to sequence, right, for example, if you want to, this is about pathogens and bacteria. Today, if you want to do some genomic sequencing for humans, that costs around 20 to 30,000 rupees. It's too high, right? So here we're trying to come up with methods where the sequencing will cost same as a blood test. Blood test is like 50 60 rupees. So if you can come up with a way where you can do the sequencing at the same cost as a blood test, then you can get to that level where you can exactly find out which variant of the virus you have and prescribe the exact medicine, right? So ultimately, this I'm talking about pathogen sequencing. Ultimately, the plan is to really get down the human genomic sequencing cost to the point where you can really do personalized medicine, right? Again, AI plays a big role because Sequencing, you get lot of data. When you sequence, when genomic sequence a single genome, get lot of data. There's no way you can manually handle any of the data. So we absolutely need the machine learning and AI to handle all this data, right? So this is one another big area which can use all the machine learning and data learning stuff. Okay, this one we're calling it Indian pathology data set. So I just talked about cancers, right? Uh, so the top five cancers we have for men are oral, lung, and other things. For women, it's breast and cervical, right? So we have a lot of cancer cases, and they're only increasing every day. And you want to develop some algorithm, right? You want to develop some diagnosis algorithm and some algorithm for cancer in India, and you want to look at some data. So guess what? Most of the public data sets that are available out there are either based on US population or UK population or some other population. There is no really good data set for Indian population. And your algorithm is only as good as the data you feed into your algorithm. So you feed all the data for US and UK population. How will it give you a good solution for Indian population, right? So the first thing you need is actually a good data set of Indian population for your algorithm to really come up with something that is pertinent to us. Right? So that's what we're doing here. We're working with almost 3-4 hospitals, right, where we're taking all their slides, pathology slides, and digitizing them and putting together this data set of Indian population. So after we do all this, we want to, by the way, everything we're doing, right, is will be open source, right? We're funded by the government and Intel also under CSR initiative. Everything we're doing, all these data sets will be out there as an open source so that anybody can go and develop solutions based on that. So that's the fundamental principle here. Okay, so those are three examples. We have more projects, but the the main message is whatever we're doing is either something that will have an immediate impact, like the screening solution I talked about, or developing a data set that is relevant for our population, right? So that people can develop solutions based on that. Right? That's on the healthcare side. I'll talk about the mobility side now. Again, the goal here, so I talked about 4 different things. The first thing is road safety, to see if we can use technology, not just technology. Technology is one aspect, right? Technology, engineering, awareness, multiple vectors to reduce road accidents. So again, this problem is not simple. So if you can see the names down there, we really have a consortium, and each one brings their own strength to the table, right? So this is one more thing. If you're developing a solution that can really be deployed out there, right? It has a lot more factors, and you really need to put together a consortium where everybody brings their own strength, right? From Intel, we bring some devices. I'll talk about that, right? From INI and Triple IT, we bring the AI expertise. And then we have CRRI, which is the Central Road Research Institute. So they're the premier organization in the country. They know everything about the roads, right? Road engineering. Right? And then we have Mahindra, who have been doing a lot of work in road safety. Right? So Mahindra has been working on the Mumbai-Pune Express Highway, and over the past 8 years, they've been able to reduce the number of accidents on that road by 50%. It's a huge number, right? Uh, so they bring a lot of expertise from their side, right? So so how do we do this thing? So I'll show a video first, and then I'll talk about the specific aspects later. Good. I'm glad you're able to hear the audio. By the way, how many of you were there in Hyderabad session? If you can raise your hands. Okay. Well, this will be a repeat for you, and maybe you can questions you can leave to the others ask. Right? You guys already asked a lot of questions when you're there. Right? Okay. So as you heard, right? So uh, this is a new concept you are trying for the first time, right? Combining lots of different dimensions, right? And the three major vectors, right? The first thing is making the driver better, right? This is the vehicle safety vector where we put a camera in the on the dashboard, right, on the screen, right. So this camera is looking at the road and doing real time analysis of everything that's happening on the road, right. The all the vehicles that are moving in front of the bus, right, whether any pedestrians are coming, right. So it gives four different types of warnings to the driver, right. So this vector is about, and that warnings come 2 to 3 seconds before a potential accident can happen, and the driver has to take he has to take action, whether slow down or uh, stop completely or change the lane. So this is the first one where we equip the driver with this camera so that he gets advance warning of any potential accident. So this, by the way, this same camera, right, we use in other parts of the world to do completely autonomous driving. So we have six of this camera in cars uh, to on all the six sides of the car, and the car completely drives on its own. So we have these cars running in Israel, New York, South Korea, lots of places, right? But that's a long way away from in India, right? So we're not as disciplined as the traffic is over there, right? So here the focus is we'll use the exact same technology, but we'll use it for driver assistance, where we'll give the warnings to the driver, and the driver has to take action, right? So that's the first one. Now, so okay, we made the driver better. We equip the driver with some technology, but it doesn't matter how good the driver is if the road geometry is bad. So that's the second aspect where we actually look at the road geometry. So this thing being in Nagpur, we looked at all the entire Nagpur network where these buses operate, right? And we have this thing called black spot, right? So I asked what a black spot was in that session, right? God of answers, right? So I won't repeat that. I'll just tell you. So black spot is the definition on the roads. This is by the Ministry of Road Transport and Highway, where they look at the data from the past 3 years, right? And based on the number of accidents and the number of deaths, they define a black spot. So when the government says something is a black spot, over the last 3 years, certain number of accidents have happened and certain number of people have died. Right? So there can be multiple reasons why there's a black spot, right? The road is narrow or the footpath is narrow. There is some obstruction, right? So we went through all those things, and then there are around 38 black spots in Nagpur. So this is where CRRI, the Central Road Research Institute, has a lot of expertise in terms of all the remedial measures that needs to be taken in each of these black spots. So I'll show you one example. So this is the second one. The first one is you equip the driver with this AI-based camera to give them better warnings, right? The second one is fix actual black spots on the road, right? So that the infrastructure gets better. The third aspect is what we're calling gray spot. So this is a new concept where we have around 250 buses equipped in Nagpur, and they're generating data every day for us in terms of these warnings. We also get data if the driver is braking really fast and things like that, because this device is connected to the OBD port, so monitor the speed of the vehicle, right, whether he's turning on his indicators or not. So we have a bunch of data, right? So this is 250 buses getting data every day. This is a lot of data, right? So what do we do with it? So here the concept with the gray spot is, with all this data, can we do prediction of where the future black spots can be or will be, right? Because when something is a black spot, that's a trailing data, right? That means you're looking at what has happened over the past 3 years. Accidents have happened, people have died. Okay, yeah, I'll go fix the road to prevent future accidents. But if this is how you're going to do analysis, that means you have to wait for accidents to happen and people to die. But that's not right. Our whole point is to avoid that. And you have all this data. So here the goal is using all this data that we're getting from the buses. We're trying to come up with a way to predict future black spots so that you can take simple measures and prevent the accidents from happening. I mean, that's the whole point, right? Now with all the data that we're getting from these things and all the AI tools at our disposal, right, can we come up with methods to prevent these accidents? So that's the third aspect, right? I'll talk more about each one of these aspects, right? So this one, first one, this is the a camera, right? So this is the camera which is on the mounted on the dashboard, which is looking outside, and then it has a very high precision GPS to see exactly where the bus is. And this is the indicator for the driver. This is like a small watch level device that is mounted on the screen, right? So that the driver gets two kinds of alerts, either a audio alert or the visual alert also. And he gets those four kinds of alerts that you see, right? The first one is a forward collision warning, right? If so the device is monitoring multiple things, right? The speed of the bus that is going, and based on the camera it is looking at all the vehicles, almost like more than 180 degrees, maybe around 200 degrees. All the vehicles, not only vehicles, pedestrians, any moving object or even immovable object in front of it, it's doing real-time analysis of all this data. Based on that, it gives this warning: hey, there is, you, in 2 to 3 seconds you might hit that bus, based on how fast that bus is going and how fast you're going. So it's a forward collision warning. The next one is pedestrian collision warning, right? If any pedestrian is coming, pedestrian or any moving object of that size, right? Even a maybe bicycle, right? And then the third one is headway monitoring warning. So headway monitoring one is sort of related to forward collision warning, right? You're just, based on your speed and the speed in front of you and speed of the vehicle in front of you, you're supposed to keep certain distance, right? If you don't keep that distance and if you go too fast, then it becomes a headway collision warning, right? A forward collision warning. Otherwise, you need to, this warning is about, are you maintaining the proper distance or not? The fourth one is lane departure warning, where if you're changing lanes without using your indicator. So these are the four kinds of warnings the driver gets, right? And he's supposed to take action based on that. Right? So let's see. So this is so now the Nagpur project has been going on for almost 1 year. This is the data based on, say, the first 3 months of data. Right? So on the top right, you see. So this is a GIS map, right? The first thing we had to do was put a GIS map of all the road network and map everything onto it. Right? So that's where all the buses are traveling within Nagpur. And then here you see the kind of alerts that we're getting, right? So the first thing you see is the headway monitoring warning, right? As you expect, Nagpur is, this is an urban network, a dense network, right? So in a highway, probably they keep enough distance, but in a city, probably they don't keep enough distance, right? They're right against each other, right? And also we expect a lot of pedestrians in the thing. So the warnings reflect that. Right? Now the thing is, okay, you have put these things. Now how do you measure the effectiveness? Right? You need to have some reference, right? You put these devices and the driver is supposed to take some action. How do you measure that, right? uh, any suggestions? Maybe let's see, before I explain how we're trying to measure it, right? You put some new device and you need to measure the effectiveness of how this is working. Is the driver taking action or not, right? Anybody wants to? No? Actually, the folks who came there already know that, right? So maybe I'll move on. Maybe in the Q&A session we'll talk more, right? So the way we have gone about it is, so we put these devices, and for the first 1 month we get all the alerts in the back end, right? But we don't turn it on, so the driver doesn't get the alert. We get it in the back end, right? So for every bus, for the first 1 month, we know how many alerts we're getting per driver, right? So that becomes our baseline because they're mostly going in the same route every day. For that route, for this guy, I'm getting this many alerts of this type, this many alerts of this type. So I have a baseline because he doesn't see the alerts, I see them, right? After that, for the second month, right, I turn on the alerts. Then the driver responds to the alerts, right? So he's whether he's taking action or not, or whether he's ignoring the device, then we'll know if the alerts have gone up or not. For example, if this month I got 100 alerts, when the driver doesn't even know. Next month, if I get only 50 alerts, then I know that the driver is actually paying attention to them and actually taking action, right? If the alerts have gone up, that means essentially he's ignoring the device, right? So this is how we're measuring it, right? And the charts you see here is showing for the first 3 months that we have seen, uh, we saw 50% reduction. That means the driver is actually paying attention to the alerts and is becoming changing his behavior to become a better driver. So what we've seen is just like with any new device, technology is not just about okay, I develop something, I'll put it out there, and then see how it works. Until you work with the end user to really adopt your technology, it's not going to work. Especially something like this, where the driver is like, I'm driving my whole life. I know how to drive. Who are you to tell me? Right? So it's not easy, right? You might think, okay, I have some really nice gadget, right? It'll help you. But just because you think it's cool doesn't mean the guy will actually adopt it, right? So we had to spend a lot of time having a lot of training and awareness sessions with the driver to show all this and get them to use it. Even after that, the first 2 months is okay, but after that, it's a new device. We explain to them, maybe they'll adopt. It again tapers down. So every 2 months, we had to actually go and have sessions to really increase their awareness again, get them to adopt it. Right. So that's one thing we as engineers don't do much, right? We always think about technology and how cool can it be, you know, how technically good it can be, but ultimately it's not about that. Those are all okay. Ultimately you have to think about the end user. How easy is it, or how convincing can it be for the end user to adapt it? And they'll only adopt it if it makes their life better, and you have to convince them, right? Typically when we're developing stuff, we don't think about all those things, right? Especially take my example, we at Intel, right, we used to develop the CPUs that go into the computers, right? And then somebody else is manufacturing the computers. So we never used to bother, okay, I'm just inside the thing. Somebody else, Dell or Lenovo or somebody else is developing a laptop or a desktop, right? Why am I bothered, right? But as we later found out, right, unless you know how the end user is using, right, you can't really it gives a much better insights, right? Now we do a lot of end user research. We sit down with the people who are actually using the computers and see how you're using them, and then translate that into, based on that, my chip needs to do all those things, right? That gives a much better user experience to the end user, right? Similarly for this also, right, or any device you do for that matter, not just in this domain, right? End user research is extremely important. Typically as engineers we don't do that, so you should really keep that in mind. Okay. Okay, second one, infrastructure safety. As I talked about, right, doesn't matter how good the driver is, if the road is bad, right, there's nothing he can do, right? So I'll just show you one video. So these are all the different black spots in Nagpur, right? By the way, to arrive at this thing, it took us a lot of time, right? Because we talked to a lot of stakeholders, the municipal corporation, the traffic department, the RTO. There are lots of stakeholders, the roads department, PWD, NHAI, National Highway Department. Everybody has their own list. Nobody talks to each other. So we had to talk to everybody, get all the data and digitize it and say, hey, there are some 120 combined list, but the real number of black spots is only this one. So we had to do this all the exercise and then actually come up with solutions, right? Okay, what can you do, right? So I'll show you one video of the kind of solutions that are proposed. There is no audio here, so that's okay. So the which one? Bottom is the current state for that particular junction, and the top is the proposed all the improvements, remedial measures. A lot of times things are not done because there is just no space and nobody in the government or the government department wants to go do something because it's tough. Somebody has encroached the road, somebody has encroached the footpath, right? But first we have to give them a plan first, right, of what to do. Right? After this, the the agency which owns that road has to go implement it. Okay. Yeah. So we have done all the analysis. Then analysis is one part. Part of the reason we first started Nagpur is because the Minister of Road Transport, Mr. Gadkari, is from there, right? And we have 38 spots. Each one of them to do all these changes that I'm showing costs anywhere from 30 to 50 lakhs, right? So it costs a lot of money to make all these changes. But it is, since the minister is there, he said, I'll find the money. First, you do the work and come to me with recommendations, right? So we are in the process of talking to all the road running agencies to implement these changes. Right? The third one, this I talked about, right? This is the what we're calling the gray spot. Okay, this again is the AI element, right? This is the first element. The AI part is already built into the camera, right? All the AI algorithms that were developed, or actually we made it into a chip, and the chip goes into the camera. It's already in the camera. But this part is actual data analysis, right? We get lots of data every day, right? If you see there, right, those are sort of the hotspots that we came up with based on all this analysis of all this data. Again, this concept doesn't exist, right? What is a gray spot? Of how do you predict these things? So we had to, and we're still revising this thing, come up with our own formula, right? So this is one thing that it's a typical problem you'll have in any of the projects you're doing in AI, right? You have a lot of variables, right? And then you're trying to make sense of all these variables. Which one is important, right? And that's a big task, right? So here we're taking all this. In this case, if you see the equation at the top, right? Here the attempt is to take all the different alerts, like the pedestrian collision alerts, forward collision alerts, and give them certain weightage. And then we're also taking the road geometry, right? You see N3 arm, N4 arm, right? So combination of all these things, and this is where we have to do a lot of analysis, right? Which one gives us the best data, right? So, and this will be same for any problem you take, right? You'll have too many variables, right? Which ones to consider, and out of the ones you consider, how much weightage you give, right? This is a very iterative process, and then ultimately you come up with something. Then you have to do ground truthing, right? Okay, we came up with 20 spots. Now how do you know? You're trying to predict something. Yeah, you can't really have a way to check, right? So we actually go on the ground and see these spots, right? The algorithm is predicting that these will be future black spots. How is the actual ground situation? So this is not a there's no straightforward method, and there's no easy way when you're trying to do something like this. So this is an iterative process, right? So we're still going through that. So this is a GIS database we had to put together, right? So this didn't exist before. The entire road network, and we have all the FIRs for all the accidents for the past 3 months, not 3 months, 3 years in Nagpur. Digitize that entire data and put it on this map. So if you pick up any black spot, we know exactly how many accidents happened, how they happened, right? This is another level of analysis, right? To see what exactly is happening, the root causes, right? Okay, that's Nagpur, right? I'll skip this. I already talked about all these things, right? Okay, then the next one we're doing is iRASTE Telangana. So in Nagpur, we're focused on the uh, urban network, right? Uh, but if you see the accidents that happen in our country, 50% of the accidents, half of them happen on the highways, right? And those highways constitute only actually 5% of the roads, right? So 5% of our road network constitutes 50% of the accidents, right? So the focus in Telangana is, so this was launched in July, to really focus on the highways, right? So we picked two highways, Hyderabad, Vijayawada, and Hyderabad, Bangalore, right? The two most densely used highways. And we working with TSRTC, and we installed around 100 of the buses that ply on that network. So it's mostly the same three kinds of analysis that I talked about in Nagpur. We'll do similar stuff, but we added one more element into this thing to get even more better insights, right? So this is the where the buses go, by the way, right? It's mostly the Hyderabad, Vijayawada, and Hyderabad, Bangalore. There is something else also, right? But mostly that's what we focus on for our analysis. I don't think anything comes to Kakinada. Maybe Samuel Court. I don't see. Maybe not. Anyway, we don't do the analysis for that network, right? Only until Vijayawada we do the network, we do the analysis, right? Okay. So one additional element in this thing is a driver monitoring system. So this is a camera that is on the dashboard that's looking at the driver, right? So for all the stuff I talked about is looking at the uh, scene in front of the driver on the road, right? So this one actually looks at the driver for these five different things, right? This is, I mean, these algorithms have taken a long time to evolve, and they're really good. Whether it is smoking on the phone or not wearing the seat belt, I think those three things are okay, right? If the camera is looking at you, the algorithms to do those three things, they've been developed for a long time. It's the last two that are really the tough ones, right? This is where AI plays a big role. So the fourth one is uh, if he's uh, sleepy, right? So for that, you need to do a lot of analysis. So essentially, track the right his eyes and at what rate he's closing them, right? So to determine whether it is just he's just blinking or whether he's droopy, right? That takes a lot of data and a lot of effort, right? So that's one thing. And the last one is if he's distracted, as in if he's looking somewhere else instead of looking straight. That's also a little bit difficult, but as not as tough, right? The camera is looking, if he's looking straight or looking here or looking here. So these two things also we track, right? So we have two sets of data, right? One is the road conditions. How is the road condition? And for these buses, we also have the driver condition. So again, a lot of data. We need to combine all this and see what measures we can do. Right? So this is the additional element for the Telangana thing, right? So some of the early analysis that we have done for the Telangana, right? This I already talked about, right? This is the network, right? And by the way, this talks about the black spots. I just talked about the black spots for Nagpur. If you see, so this is the Hyderabad, Vijayawada, and these dots you see are all the black spots in the Hyderabad Vijayawada highway, and then the blue spots you see here are on the Hyderabad Bangalore highway. So we have around 48 here and around 60, around 110 black spots. It's a lot of black spots. Again, we have to do similar analysis and see what are the remedial measures. Right? So one example of the early data from Hyderabad, for example, if you see this graph, right? This is combining two kinds of alerts, right? So this is for the month of September and October, right? Here we're combining two kinds of alerts: a headway monitoring HMW alert and LEW alert. LEW means lane departure. The driver is turning into the other lane without using his indicator, right? And then after that you got a headway monitoring alert where the distance between the bus in front of you and you is too low. So we're combining these alerts to see if they're coming almost at the same time. That's what's happening is the driver is taking a big turn and then going very close to the bus in front of him. So very high chance you'll have an accident, right? So these are kind of analysis we're doing of all this combination. And here you see where that is happening, right? On the highway, if you see all these these blue spots, that is where most of the drivers are engaging in that kind of behavior. And then we also because we also take the driver roster data and map it, so we also know exactly which driver is doing it. So if we feed all this information back to the depots, and then we give every month the top 5 and the bottom 5. So the depot manager, for the top 5 drivers, they get some incentives. The bottom 5 drivers, they get to go to the classes, right? So this is a constant reinforcement we'll have to do, right? Because you got to have some incentive, right? For the drivers who are doing good, you're like, okay, I'm doing better with this device. What am I getting, right? You got to have some incentives. Technology is all fine. At the end of the day, you have to do something more than that. So we're going to do a lot more analysis. Similar thing for Nagpur too, right? Okay, that's iRASTE. Then I'll talk about few other projects. Then we'll open up for questions. I talk about road infrastructure and enforcement solutions. So here the plan is to actually take simple cameras, put them on the car, and collect the data, or not collect the data, or have algorithms that can do automatically a lot of things that the police or other people do manually. For example, pothole detection. Right? So this one is not easy, but this is completely automatable. So we actually put one camera on the car, and then that car goes out, and you can get exact pothole map of where exactly the pothole is. That we have already done, but now we're trying to also do the depth of the pothole, how big is a pothole, and things like that. Right? So this, what you see, is the outer ring road. Right? So I know this. So I traveled over the last 2 days, right? Bhimvaram here, right? So I've been traveling here, right? The question is, the government will want to do something once you give this data. Otherwise, what's the point, right? So at least for this outer ring road, there the government actually cares because it's one of the highly used thing. So they want this thing immediately so that they can take action, right? And we can do this in a completely automated way because there is a lot of petrol vehicles on the going around this road, and we just put a camera and this thing is generated every day automatically, right? So this is one thing. Second thing is tree counting. Again, there's a lot of emphasis on planting trees and greenery, green cover, right? Again, taking Hyderabad as an example, right? They did a lot of work over the past 9 months. The question is, how many of those trees are alive, right? How are we doing, right? Again, sometimes somebody goes and checks something and writes in a register, right? Again, this can be completely automated. We just put a camera, the camera looks at everything and then counts all the trees, and we can tell exactly this area is where all the trees survived, this area is where trees didn't survive. The same thing we do for other stuff, by the way, right? In terms of I didn't show it here. We are working with GHMC right now, where in terms of the cleanliness of a given street, right, of where to every day morning, where should I send my crew to clean the roads, right? And also the lights, right? It's also very easy to do, where first of all we count all the light poles automatically, or in the night you can see which lights are not working, so that they know where to send the folks to replace the bulbs. A lot of this can be completely automated, right, using this AI and data science. The second one, some folks may not like it. This is more of enforcement solutions. So work with the traffic police, right? They actually, so they have a lot of CC cameras. So right now we're not working with that feed because that is not as clean, right? The CC camera feed is not as clean. So right now these examples that I'm showing you, these are based on camera, just based on the car, right? So if you see this thing, right? So this has two solutions implemented in there. This can do both triple riding and also helmet violations. So if you see this guy, right? No helmet, no helmet, no helmets, and triple rider, right? So this can be done really good, right? By the way, it's not easy because there are a lot of false violations. You only need to look at people who are riding a bike, not somebody who is walking without a helmet. So there's a lot of false positives that come on. So the algorithm needs to take care of all those things, right? And also the driving conditions, right? It's easy to do when the weather is really good, but when folks want to deploy a solution, they want to deploy for any weather, right? It can't only be good weather. So there's a lot of work that needs to be done for an algorithm to really make it robust. So we have some of these solutions that we're working with the enforcement folks, right? Then IDD, right? So I talked about this is a data set that we've been working almost for 5-6 years now, right? So if anybody wants to work with Indian driving data conditions, right? This is there are other ones right now, but this is the biggest data set that is available out there, right? And the latest one. So this is all the number of users and all that stuff, right? By the way, mobility doesn't mean just the cars on the road. As we learned, once we put this data set out there, uh, we have seen a lot of other folks who want to use this data set, right? For example, we have, of course, people who want to work on the mobility on the road work on this. This data set right now, we have around 8,000 users around the world, right? One user, for example, is a robot manufacturer in Japan, right? They make robots for senior citizens at home, right? So the robot needs to work with the right senior citizens, right? Your grandfather or grandmother. And further to work properly, it needs a data set where anything can come from any side, really unstructured conditions. Oh, what better than our road set, right? Where anything come from any side, right? So they've been really using this data set to train their robots to become much better, right? So there are a lot of these other use cases. An example, you see these vacuums. I think the Roomba is one of the company, the automated vacuums where you leave it there and it cleans the floor, right? So those guys are also using this data set where the machine can have a lot of unstructured conditions, right? That needs to get trained for, right? So we continue to do this. The latest one we have is what you're calling IDD 3D. Uh, so far, all our data sets have been using only camera so far. But it's the first time we have multiple cameras and we also have a lidar, right? Lidar will give you three-dimensional thing like radar. So that is also added into the data set, right? So this gives you a much more granular data, right, to deal with, right? But it also makes your analysis and your algorithm also a lot more complicated, right? So a lot more stuff you have to do to uh, dealing with images. The algorithms and the AI stuff has been there for a long time. It's pretty mature. Now you want to deal with new kind of data, lidar data, radar data, and other things, and also the night vision data. Then you'll have to come up with new methods to deal with all this data. And the last thing I'll talk about is a platform, right? So you need some platform to collect all this data, right? So this IDD data set, we used to get a car, put some cameras, collect the data, right? And then again, the car goes away. So now we have built a platform. So this we use it, but anybody else can also use it, where it has a lot of cameras on this car, and then it also has a lidar on the top, and also it has a lot of processing power in the car itself, computers. So we use it for ourselves, but the reason we build this is for anybody, right? Any company wants to develop some new algorithms, or even you guys want to develop some new algorithms, but you need a data set that doesn't exist today, right? What you can do is you can use a platform like this. It already has bunch of cameras and all those things. You can put a new kind of camera, and then you can collect your own data so that you don't need to build your own car and all that stuff. For example, say you want to develop some algorithm that looks at all this camera and also monitors the driver's, say, physiological parameters. So you can add some sensors, right? On top of all the sensors that are on the car, put some sensors on the driver and then collect that data also. And a combination of all these, you can do this analysis, right? So there are various things. If you want to do some new stuff, then you can use this vehicle and add your own sensors and do it. That's the whole idea behind this thing, right? Again, for GHMC, they wanted to run this for a few roads in Hyderabad. So they used this car, ran this for 2-3 days, collected all the data they wanted to collect, and then they put out a big challenge where something like, I think, almost 100 startups came in. It was open to anybody. I don't know if any of you might know, this ran for the last 1 month, right? It is open to anybody to come participate, right? They give you this set of data. and then you have to right, predict all the potholes, right? The best algorithm gets 15 lakhs, right? So things like that, right? That's the first challenge we ran. Okay, one last thing I'll talk about, and I'll finish this and we'll open up for questions, right? So this is also one project we're doing. One of the professors at Triple IT, he's been working on this for the past 20 years, right? He works with the National Disaster Management Agency. So he has two applications. The first one is called Rapid Visual Survey, right? This is for people. NDMA is the National Disaster Management Agency. They are the first responders to any big calamities in the country, floods, earthquakes, and all that stuff, right? So those guys, when they go somewhere, especially earthquakes, this is for earthquakes. I mean, you see these kinds of houses. The thing they need most is to know whether that structure is safe enough to go inside or not, because they need to rescue somebody, right? And most of the times, based on their experience, they make determination. Okay, based on experience, I know this is good or not, right? But what you're trying to use is, again, here use AI, right? Where we're trying to collect as much information as possible of the kinds of houses that are impacted and create a database, right? And then build an application based on all this data, where we will give this application to the first responder. He goes there and then he clicks the picture, and this AI algorithm will tell him, based on all the learnings that we have, yeah, you can go this or not, right? So that he doesn't need to rely on his experience or somebody else's judgment to go inside the house. So that's one, right? Again, our goal is to actually use technology that's actually deployable and make an impact on the ground, right? So this, we pick this up because this can make a real difference, right? And then the second one is something called Earthquake Disaster Risk Index. So they have this EDRI indices they developed for entire country, right? For example, uh, especially the municipalities, right? In a municipality, they can do this assessment for the entire municipality, go to every house and say, this is the risk index. And they have a bunch of parameters. Again, what we're trying to do is develop a solution based on a drone image, right? So the municipality guy will go with this application and a drone. He'll deploy the drone will look at the entire, say, a building. They want to assess a building. Based on that image, we'll say this is the risk index, earthquake risk index for this building. They want to do a lot more, whether that's according to the norms or not, right? So that's a different thing, right? Norms is a different thing, but here it's about earthquake stuff. So this because it'll have a real impact on the ground, right? So okay, guys, that's the last one, right? So I'll open it up for questions.
Good morning, sir.
Morning. Go ahead.
Sir, how can a driver can eventually take a decision within two to three seconds within a instruction?
Yeah, good question, right? So a lot of research went into this thing, right? Uh, Now you're giving a warning to a driver. What is the optimal way to go about it, right? Uh, so so Intel bought this company called Mobileye, right? And they've been working on this stuff for almost 15 years now, right? So we have done a lot of work where we sort of varied this time, right, from 1 second to almost 5 seconds, right? Thing is, if it's 1 second, typically, the I mean, these things, by the way, this technology only kicks into action once you cross like 20 to 30 kilometers per hour, because less than that you don't really need this, right? So you're going at 60 to 70 kilometers per hour, right? Typically, or highways 120 plus 100, right? So there is that speed, right? And then so there's 1 second is too less, and if you 5 seconds is too much, right? Then you get too many warnings, then it's not useful. So we did a lot of research, and then we after all that, the outcome was 2 to 3 seconds is the optimal time, where he driver has enough time to respond, and also it's actually useful, right? It's actually a real alert, right?
Thank you, sir.
Any more questions?
So by the way, one more thing. So these algorithms, right? Again, talking, of India, right? Originally, these algorithms were developed. Mobileye worked on all the data sets from US and UK. That's what their target market was. To deploy this in India, right? So they did a lot of work here where they put these cameras and then uh, went all over India for 3 years, right? Because you have a lot of conditions that you don't see out there, right? Here you have people coming and say stop, right? They're not going to see that anywhere else in the world, right? And they'll just cross the road, right? So they had to customize their algorithms for India, right? And they actually have a real deployment out there. If you buy the Mahindra XUV 700, the same camera that's we are using is in the Mahindra XUV 700. So if any of you guys have it, right, or drive in it, so you can turn on the ADAS feature and you'll get the same alerts. You'll see it. So you can then judge how good or bad it is, right? Whether the 2-3 seconds is good enough or not, right?
Yes, you have a question.
Good morning, sir. I'm Bhavana from CSM. Actually, I want to bring to notice to you that actually during a drive when with my father, I listened a sound, sir, sensor sound. It was warning a belt, a seat belt. It warning the driver to have the seat belt. I asked to my father that what's that sound. Then he said it is a seat belt sensor. It is warning. Then he set the car to the roadside and set the seat belt backside. Then the sensor automatically stopped. What actually my father didn't hold the seat belt, sir. But he set the seat belt to backward, then it stopped working and it stopped giving the warning. What I'm trying to say is not just my father, like so many people do feel irritated to keep the seat belt or some other warnings what the sensor give us. What I'm trying to ask you is, you said we'll set of sensors to the car. So what they'll just do is they just give warnings. So what I'm trying to give an idea is that can't we choose a better way than the sensor?
We can choose a better way. By the way, so what did you advise your father when he did that?
I said
Did you
don't do
ask him to
it.
actually really wear the seat belt?
Yes, sir, he would.
He wore it. Okay, that's good, right? See, we can have a better way of giving the information to the driver, right? But fundamentally, it comes to compliance, right? If the person doesn't want to do it, right, then it doesn't matter how much information you give the person, right? Then it doesn't really matter, right? It ultimately comes to technology is technology, right? It is giving you something. If you don't want to use it, doesn't matter how nicely I give it to you. So it comes to that. That's the reason we do a lot of work on awareness, right? We sit down with the drivers every 3 months. We have a awareness session with them, and then also have incentives for them, right? And also like these gray spots I talked about, right? In some of the gray spots, we work with NGOs to go to all the colonies around the gray spots, and we do a lot of awareness sessions, right? uh, some people listen, some people don't. It's not easy, right? Ultimately, if people don't want to use the technology, not much we can do, right? I mean, I see when I go in taxis, right? uh, the drivers, if you sit in the front, some of the cars the passenger also has to wear, right? So they already have a right, you have to wear the thing, that clip that they have, they already disconnected the clip. Like, sir, just put the clip in the thing, the sensor will stop, right? That's completely defeating the purpose, right? But then again, it's up to the driver.
Thank you, sir.